Hello friend, my topic is time to stop the dewatering system and why it is important to know the time to stop the dewatering. But basically, why we need the dewatering? When we are making the building underground, maybe for the basement is maybe one or two basement, and the building is near the sea or the water table is very high, so we cannot do the construction in the water. So we have to remove the water before to start the construction and during the excavation. So the dewatering is required to construct the building underwater, maybe near the sea or maybe the area where the water table is very high. So we cannot construct anything in the water, we have to remove the water. So the system to remove the water is known the dewatering system. And this dewatering system is being carried out by the third party and is not basically topic of the civil engineering. So why the project manager or the project engineer should know time to stop the dewatering, which will be stopped by the dewatering contractor who is being hired by the main contractor or by the client. So why we should know time to stop? Because the time is a money and the contract signed with the dewatering contractor is with the unit rate of the day. So as long as we need the dewatering, we have to carry it, but when we should stop is very important to save our extra money to pay the dewatering subcontractor. So this is the objective of this video, why we should know time to stop the dewatering for the buildings which we are constructing under the water. So our factor is here to save the money is the time. So how to calculate that time to stop the dewatering system? And that calculation have one formula. The weight of the concrete which we are going to pour in the structure during the construction should be more than the 1.25, or I can say the 25% more than the weight of the water. So how to imply this formula to satisfy this condition? And the condition is it should be more than, the weight of the concrete should be more than 1.25% or to 25% the weight of the water. So I can explain to satisfy this formula here. Say this is my area of the construction and 100% construction. The length of the construction area is L and the width is B. If I draw the section XX, the total depth of the excavation is H and the water table is below the H1 height. So how we should know from where the H1 can be find? This H1 being shown in the borehole log in the soil report, which is being investigated before to design the project. So the soil report have this height which is variable as per the location or the plot to plot or the project to project. So H1 can be easily find from the soil report. Now our excavation is up to the formation level. Formation level is the bottom of the concrete or bottom of the raft or the bottom of the foundation, I can say. So H is the excavation depth and the H1 is water table level. So we should be calculate from H2 and this volume. So the volume of the water should be calculated H minus H1, that will be the H2 into area of the construction. So area of the construction L into B. So L into B multiply by height of the water where we have to construct the structure within the water table. So H2 into L into B will come meter cube because we are applying in the height, length and width in the metric unit. It's in the meter, it is in meter, and that also in the meters, it will be meter cube. Now this will be the volume and here the weight. So the weight of the water will be the volume which will be calculated here multiply by 1.03 ton per meter cube. You may surprise why 1.03. The density of the water is normally 1/998 ton per meter cube, that is for the potable water, or I can say drinking water, but we are considering this 1.03 for the water of the sea or saline water. So saline water is heavier than the potable water, so the density is 1.03 ton per meter cube. So if you multiply by the density, we will have the weight of the water, the weight of the water. Now weight of the concrete, this is a factor we should consider with the time, with the time. Suppose we started the foundation, then the walls, the core walls and the columns, and maybe one slab, maybe second slab. So we are starting to adding this concrete stage by stage, and the weight of the concrete should be 2.5 ton per meter cube. So we are cumulative adding, say this is the weight of the concrete for the component number 1, this weight of the concrete for component 2, weight of the concrete for component 3. If you are adding all, it will be a VC, a cumulative weight of the concrete, which will be in the meter cube. So meter cube into 2.5 ton meter cube is the density of the concrete. So this will become the weight of the concrete. So we will be continue to calculate all the concrete weight till this condition is not satisfied. So we are going to pour this concrete in different time. So time will be increase, we will reach this stage when the weight of concrete is more than 1.25 times weight of the water. Now the time to explain what is the 1.25. See this water table during the soil report investigation have at this level, but it may go down, it may come up because it is seasonal factor. This is not under control of the any human factor. So this may go up, this may go down. How much will go up, how much will go down? So we should have some factor of safety for the variation in the water volume. So we consider in the normal, in general condition, that if we can increase the water volume of the water by 25% or the weight of the water by 25%, this condition will be within in a safe factor of safety or in a safe time to stop. So there is no risk while we stop the dewatering, there is no risk to any X factor which may harm the structure due to the bouncing factor. So the volume of the concrete into the weight of the concrete should be more than the volume of the water by 25% more the weight of the water. So the moment this condition is being satisfied, that the weight of the concrete should be more than 1.25 times the weight of the water. Now this is a factor of safety. You may know, or we must know, this factor of safety is varying location to location. In a general case, when we are very far away from the sea level, or we are constructing in a general area where there is no sea around, so the 25% factor of safety is enough for the general condition. If we are nearby sea, then the factor of safety will be increased by 50%. But we are exactly very close to the sea, then the 25% and 50% is not enough, because the sea level is varying maybe twice in a day, and this may vary by 2 meter to minus 2 meter to pulse. So this is very risky. So we should increase the factor of safety by 2. So in this condition, if you are very close to the sea, the volume of concrete or the weight of the concrete by multiply by 2.5 ton per meter cube must be double of the weight of the water, because of the variable factor and factor of safety. So the last condition is very close to the sea. The second condition of the 50%, it is where we have the more risk and maybe close to the sea water, and the 25% we are away from the sea water, but still we are constructing the building in the seawater. So we should inform well in advance to this agency who is carrying the dewatering system that our weight of the concrete is going to reach by end of this month or by this date. So we are hereby informing you to stop the dewatering by this date. But he cannot stop just by our information to stop the dewatering by this date, because there are the other factor we should carry it out, or the project manager should execute with the help of the dewatering contractor. So my today video is the time to stop the dewatering, and time is that the weight of the concrete must be more than 25% weight of the water in a general condition, or the 50% more than the weight of water in the other condition, and if you are very close to the sea, it must be the double of the weight of the concrete, weight of the water. So to keep the structure safe, when we will stop the dewatering, there should not be any risk to the structure to bounce in the water. Hope the concept is clear for in this video. In my next video, I will explain that what are the factors to be considered and how the dewatering to be stopped, and what is the involvement of the project manager or project engineer with the other agency. The moment we instruct him to stop the dewatering, that will be also a factor to be costed to the civil engineering company, as well as the dewatering company may use to adding the cost on the dewatering. So that is the second factor I will explain you in my next video.